Thank you all so much for joining us this evening. Tonight, I am very, very excited to welcome Dr. Clifford Johnson. I've had the joy of working with Clifford when I was at the American Physical Society, and I'm excited to welcome him here this evening as part of our lecture series. Dr. Johnson is a professor of physics at the University of Southern California. His research as a member of the theory group there focuses on the development of theoretical tools for the description of the basic fabric of nature. He was awarded the National Science Foundation's Career Award in 1997, the Institute of Physics Maxwell Medal and Prize in 2005, and a Simons Foundation Fellowship in 2016. Dr. Johnson's work in science ranges from teaching and research into black holes, particle physics, string theory, and cosmology, to public outreach where he strives to put science back into general culture. He helps artists, writers, and filmmakers incorporate science into their work and appears on several TV series and online shows. He has been a science advisor for many shows and movies, including Nat Geo's Genius, Marvel's Agent Carter, and if you haven't watched the show, you have to. It's one of my favorite shows of all time. Thor, Ragnarok, Avengers, Endgame, Infinity War, and more. Johnson recently published the Dialogues, Conversations about the Nature of the Universe through MIT Press, which allows readers to eavesdrop on a series of dialogues set in locations around the world about cutting-edge scientific topics. In this talk, Johnson will discuss the process of turning complex scientific topics into compelling visual narratives. This talk will be graphic, but in a family-friendly way. And with that, I will pass it over to Dr. Johnson. Thank you so much.
Thank you, everyone, for attending. Thank you, Rebecca, for the generous introduction. It's a pleasure to be here in the sense of virtually here at Fermilab, as it were, and I hope everyone is comfortable and we'll have a little chat. And hopefully there'll be time at the end for questions, so do hang on to those questions that you may encounter as you go along. So I'm going to share some slides. One of the things that I'd like to emphasize is the mission itself. It's a bit grand, but I think it's important to, at the outset, remind ourselves, or for me to remind you, why I do this. Beyond the teaching and research that I'm, that's my day job, as it were, I do think that it is important to try and communicate what it is we're doing in science and get people excited about science, have people engage with science. Not because I want everyone to turn into scientists, but I do think that science is part of our culture. And so really should be something that is in everyone's vocabulary to some extent. And to do that, we need to be out there as scientists in the world, helping people do this. Once upon a time, people gathered, you might recall, in the old days, out there in the world with no restrictions, and they talked to each other. And one of the things that I want to hear, I do sometimes hear it, but I want to hear more of it, in those conversations when I eavesdrop, is I want to hear science come up, just like conversations about aspects of the arts or popular culture or celebrity gossip or what have you. I think science should be part of that whole mixture because that's all part of our culture. So my job in part, I think, is to put science, as I often say, back into the culture where it belongs. So that's the mission. So what I'm trying to do here is remind you of that thing that I said, people out there in the world gathering, conversations going on. And one of the things I try and do, as do many scientists, is get some material into those conversations. And we do that, for example, by giving public talks of various kinds, like this one, for example. Or maybe we do a demo at a local museum and get some people engaged. And one of the great things about that is that it's very one-on-one, very personal. It can be, and there's a trade-off, right? You have 100% control of the material that you're delivering and a modest audience of, say, a few tens or maybe a couple of hundred people. And so that's great. You can scale things up a little bit. So as was mentioned, I appear on TV shows from time to time, and that means you can reach a wider audience, but you have as a trade-off, perhaps less control over the material. You're maybe helping with some advice behind the scenes, but you're mostly doing a little bit as part of a larger thing that you don't have any control over, and you keep your fingers crossed that it's not complete nonsense. And then, of course, as mentioned, you can go all the way to the other extreme, which is, as I sometimes do, act as a science advisor. You talk with the writers' rooms and the writers and the directors, and you hope that some of the scientific ideas you scribbled on the script or told them over lunch makes it into the movie. But you have zero control over that. But the trade-off is you get millions of people maybe talking a little bit about a scientific idea that got embedded into the story. So it's a lovely spectrum. And somewhere in sort of in the middle of that spectrum somewhere are books, which is what I'm talking about today. And so it's quite traditional, quite standard for an academic such as me to write some book explaining about what thing they're excited about. And people would ask me, for example, when are you going to write your book for the general public? Because you seem to have some success in explaining things, so usually you write a book. And over 23 years ago, I began to think about this and the fact that I didn't feel there was any urgency to do that. I felt that I wasn't in a hurry because I felt that something needed to be changed somewhat about how we do these kinds of books. I wasn't super excited about going out and doing another one. And I probably will go out and do a traditional book. And in fact, this thing you're seeing here is a snap from actually a more technical book that I had put out around that time. But the point is that I was a bit bothered by the fact that we write these books as academics, especially in our field. There's some excitement by a very narrow group of people who are predisposed already to read those kinds of books, to seek them out, to go to that corner of the bookstore and find those books. And that's great. That's a perfectly fine model. And I'm not saying those books shouldn't be written. I just feel that we can do more. We can reach more people. We can get more people who don't realize that they might be excited by some of these topics to be engaged as well. So one of the things I was trying to think about is how to do that. And one of the things I realized was perhaps part of the thing that could change is this model of having the single voice, the expert telling you as the reader what to think about this topic, and you close the book and then you're done. Wouldn't it be interesting to try and engage the audience somewhat, to in fact make them feel involved somewhat? So that led me to the idea of perhaps having multiple voices in the book. And of course, the old masters already thought of this. I realized that dialogues was what I wanted to do. And then I realized that, oh, wait, yes, of course. Very famously, you have the ancient Greek philosophy discussions in the form of dialogues. And also Galileo. Some of you may know that in Galileo's revolutionary discoveries using early telescopes to see what was going on in our solar system and realize so much that he's famous for now. Those were not communicated in some scientific paper, which, the model for which hadn't even existed yet. Those were actually in the form of popular level, for those who could read, books, which were dialogues. And so I realized that actually what I'm doing is rediscovering an old idea, which is to have dialogues between people playing around with these ideas. And so you get away from that single voice. One of the things I also realized was it would allow one to, and the model of the book at the time was to have maybe also those conversations, and then you would see some of the scribblings that you do when we explain things to each other, perhaps as scientists. And in fact, I got very passionate about the idea of showing the tools that we use when we are discussing science to each other as scientists. Because traditionally what happens, this is just a slide from a blackboard of a talk of my own. And look how visual that is, right? I'm not expecting you to to understand what this is about. But you can see just how visual it is. And we're encouraged to hide that by editors and book publishers and the like. And the famous adage that Hawking talks about a lot is this business of every time you have an equation in the book, you halve your audience. I think that's a mistake. It's like we're writing books about musical performance, but we're afraid to show the musical instruments. And that's sort of ridiculous. There's got to be a way of doing it that doesn't scare the audience and doesn't buy into the cliche that math is scary and stuff like that. So we should be able to show equations and diagrams and things right alongside everything else. All those wonderful visual things that we use to discover the science, we should be able to use in explaining the science to each other and to an audience, rather than just write pages and pages and pages and pages of words. So that was sort of the idea. And then it grew in my mind. It's sort of this, like I said, this was over 20 years ago, and I still didn't do it. But I began to think about it. And I thought, well, wouldn't it be nice to see who these people are? That would be interesting, because we're intensely interested in who people are. We're interested in people. We see two people sitting together and we wonder what they're talking about, how they came to meet, where's this conversation going to go, things like that. So why not show some of that? And that would be a way of engaging people and pulling them in. And then maybe you get people engaged in the conversation as well. So I took some time out to learn how to do this. I'll say a bit more about that later on, teaching myself the drawing techniques you need in order to do that. And then I got a bit carried away, and eventually it turned into the book. So what I want to do is to try and delve a little bit into what this really is. There are a lot of misconceptions about what this medium is. Often it's associated with superheroes. That's the classic business of mixing up the medium and the genre. Let's not do that. Let's talk about the nature, the graphic novels, or narrative art, if you want to be sophisticated, pretentious perhaps. Narrative art as a means of communicating serious ideas, not just in the form of sort of fun comics for kids or what have you, which is also a great and important area, but for everyone, for grown-ups as well. This has already happened, well, in the rest of the world a long time ago. It's happened in America, perhaps a little bit more late, in other areas of the book world, in the literary world, in memoir and other areas where you're communicating serious ideas and messages and stories for grown-ups with graphic novels. And I claim that actually, until recently, this has not been happening. This important tool has not been being used to talk about science. And that's what I wanted to change. So let me tell you a little bit about the book. And indeed, yes, it's full of pictures. But an important thing to understand about this whole thing is that it's a combination of three kinds of things: pictures, symbols, words. They work together and they support each other in a certain way. And in a way, what happens is that words can be symbols, can be pictures, and so on and so forth. All these different things can play the role of each other in different contexts and swap back and forth. And then together they support each other to drive a narrative along. And that's sort of the core idea. There's a lot to be said about this. And there's a lot of research, scholarly research, but also just practical research by people who are making comics and graphic novels out there, about how this works and why it's a very powerful and unique medium. And I still think it's rather underappreciated. So I encourage you to find out more. Here are three examples, I think, of some of the books. Well, usually the first two people tend to recommend a lot. I would say also there's a more recent one by Hilary Shute, which goes with MacLeod and Eisner, I think, to make three really wonderful books that you might want to delve into to perhaps learn how powerful and important this medium is. Now, one of the great things then is that one can have the thing on the page as you expect, right? Which is people talking about science and some words and some pictures with the settings. And so there's a lot of that in the book. One of the things I discovered a happy accident was also, oh, wait, when you can see who's having conversation, because my original plan was just, it was the same two people talking. You can really change things up. You can have different people talking. And this is a great way of showing that actually there's many, many different kinds of people who are engaging in the science. You're not just showing it, and then you, the reader, are not just eavesdropping on those conversations and picking up the science, but it's encouraging you to have conversations as well. You're just like everybody else, all these people having conversations. So that was an additional bonus of the whole thing. And then, yes, as I said, I can have people talking, but I can also show on the same page in a way that hopefully isn't too scary, in the cliched way that math is scary. One can actually show some of the tools of the trade and show some of how the science is actually done rather than just saying words. And one of the things that can be done, for example, in the book, is as there's one person talking and he says, you know, there are these equations called Maxwell's equations, and they're incredibly beautiful. And the usual thing happens. The person he's talking to says, oh, well, you know, beautiful equations, what does that mean? All right. When, you know, she says, I love science, but when equations start showing up, it gets messy. And what you can do right there, as is done in the following pages, is that they go through together with a pen, pencil and paper, and they unpack these equations. Now, you don't need, it turns out, to understand everything about differential vector calculus in order to understand what those equations mean. Those symbols, you can sort of have an intuitive sense of what they mean, and he explains that, and then how they move around the page in order to justify this phrase of the equations being beautiful. And these equations eventually, as he then explains, helps us understand how light works and how the universe at large and space and time work in this beautiful way that we hadn't understood before these equations were discovered. And this is all about having the freedom to have those equations and show them, and to bring people in to being able to unpack those equations. The analogy that's given in that point in the book is rather like going to an art museum. And people don't run screaming because they don't understand how to paint, or all of the theory of color and light and paint mixing and different media that goes into producing a painting. It's okay if you don't know all of that. You can still get something from it. And it should be the same with equations on the page in these kinds of books. So I'm advocating for more of that. Show the tools that we use. Show the musical instruments if you're talking about music performance. There are all kinds of different people, as I said. There are children, there are grown-ups, there are different settings. There's some children in their home, there's some grown-ups in some part of the city somewhere. One of the fun things I do is use a variety of locations, real cities. I don't say what they are. It's sort of a fun game people have, apparently, of trying to guess which city some of these conversations are taking place in. So it's another way of bringing you in. You're curious about that environment. All of this visual stuff is going to help make the book sticky, as it were. Then there's there's another very important aspect of the medium, which is how powerful it is because the reader has control over how they read it. And that's different from a movie. People often mix up graphic novels because famously there's so many graphic novels that have become movies, movies that are based on graphic novels. People think of graphic novels as a bunch of stills. And you know, when people heard I was working on a graphic novel, the joke is, oh, right, it's going to be a movie. Well, actually, you could do that, but that's something different. Graphic novels are not movie stills. There's so much more to what you can do. And what I'd like to do is tell you a little bit about that in the service of explaining science. And you can already see that here. These panels come up, and you can see there's a setting, right? There's two people in the real or constructed reality that is the cafe that they are in. There's the real table, but from time to time, they can actually look down. In addition, sorry, you can look down on the table that's in front of them, and I can use that as a canvas for showing some of the things. Again, it doesn't matter if you don't get it, doesn't matter if you don't understand all of those things, but they help bring to life at whatever level that you're comfortable with. You can choose what you read and what you don't read, what you get from this page. And that's rather, and you can take your time. It's not sort of whizzing by as it would be in a movie. You can take your time. You can read it in the order that I designed it for you to look at, but you can read it in a different order. And that's one of the beauties of the whole medium. This brings up another interesting aspect, which is the multi-layered aspect of the whole game. The fact that I have these real people having a real conversation about real science. Okay, well, they made up people, but they present, presenting them as a reality of the book. But they can now pick up a piece of paper and write some equations. So they are using a medium within the medium as well to talk about things to each other and to you. So that's kind of interesting. But you can do a lot more than that. For example, there's an important analogy that I like to use when it comes to discussing aspects of my own research, which is quantum gravity, trying to understand gravity at the quantum level beyond what Einstein taught us is true about gravity, which is that it's the flexibility, the fact that space and time can warp and bend in various ways, and we interpret that as the gravitational force. We need to go beyond that to understand gravity at the quantum level, to understand what black holes really are, the very, very earliest moments of the universe, and arguably the birth of everything that we understand today in the universe owes its physics to understanding quantum gravity. And the analogy is that we need a new description of space and time that is more adapted to asking and answering questions to do with quantum physics. And the analogy is water. So you take a glass of water, and it has certain properties that we're familiar with from a fluid description, fluid dynamics. It has wetness, it can flow, you can change its shape, pouring it into different shape containers and things like that. These are all important, true properties of water. But there's a whole other description of water, which is to do with its atomic structure, its molecular makeup out of oxygen and hydrogen. And that's important for understanding completely other questions about water. No single water molecule knows anything about wetness or the shape or the fluidity. All it knows is lots of things to do with atomic properties and its neighbors and things like that. But somehow out of that emerges this other description, which we're more familiar with. Something like that is happening with space and time, we believe. And so we're trying to get at that sort of atomic structure, if you like, of space and time to understand those issues I talked about. So how do you talk about that? I could say all of those words in a book in the usual way, or I could just have a character pick up a glass of water and splash it around, and that's what she does. And she splashes it around, and then you engage more with that idea. It pulls you in again. And so more happens with that, but that's just one of the things I wanted to show you that you can do with the real and the abstract right next to each other on the same page. Here's a very famous abstraction. It's a very famous cartoon. Of course, people who know about Fermilab know this very well. This is a Feynman diagram, and you use it to compute all sorts of important things about particle physics. It is arguably the most successful tool in the history of science ever in terms of being able to calculate to some level of accuracy and then go out and go out and measure it and check that calculation. So famously, you can compute properties of electrons, for example, in quantum electrodynamics to the 12th or 13th or 15th decimal place accuracy and go out and measure it to that accuracy. And as Feynman famously said, that's equivalent to specifying the distance between New York and Los Angeles to greater than the accuracy of a human hair. Actually, that was some decades ago. It's probably more accurate than that now. And of course, this is done in many areas of particle physics. It's an incredibly powerful tool, but it's a cartoon. It's an abstraction. And you use these cartoons to calculate, you put them together in certain ways. And you can, in fact, read them like cartoons. I put comic panels around it. So you can actually read it as you would read a comic, if you know those rules, sort of going around in the orders of the panels tell you. And you would indeed read it the way a scientist does. You can also read it in other orders as well, as is your wont. And you will also uncover physical processes that way. And scientists do this all the time. It's a cartoon. So if anyone tells you that cartoons are sort of nothing to do with serious science, just tell them Feynman diagram and let them Google it. And here are some whimsical cartoons of things we've discovered using Feynman diagrams and so much more. So here's an example of symbols, right? You see in the context of physics, you have a tree, apples, and you immediately think in gravity. There's a Feynman diagram, which itself can be a symbol. And this is part of a whole discussion that actually, I can't remember if this made it to the book, which is all about the failure to find a Feynman diagram description of gravity, which is one of the quests to understand quantum gravity. We need to find new tools. And it leads to some of the things that you've heard of, various approaches that go beyond particle physics, constructions like string theory and loop quantum gravity and things like that. So one of the questions is, how do you describe some of those ideas? And again, very visual things can be done that can really bring you in very rapidly to some of the ideas that we use in the actual doing of the science itself. And then one can actually use symbol and visual metaphor in various ways that can be useful. There's a lot of discussion, for example, of the idea of the theory of everything. As soon as people start talking about certain areas to do with quantum gravity, it comes up. And there's a discussion like that in the book. And the analogy I tend to use, I like to use there, is the whole business of theory of everything. Is that always somewhat provisional? Is it always a box that you discover, but actually later on you find you need to put it into a bigger box, and then an even bigger box, and so on and so on and so forth. Again, a very visual metaphor that is well adapted to this medium. You can also play with, in terms of the settings and the decorations, you can echo ideas visually. These two people are talking in a cafe somewhere about the many worlds interpretation of quantum mechanics. The whole idea that this probabilistic framework might mean, in some people's minds, that perhaps whenever you make a choice, whenever you actually see what the outcome is, the other outcome, quote unquote, happens too, but it's branched off into a different universe. So you have this idea of branching. And it's a little on the nose, but it is kind of nice too, while they're having that conversation, in the decoration itself, we're looking down at them through branches. And it helps, I think, glue together things and again, engage the reader in different ways, sometimes subconscious. If you like, the sort of Easter eggs of the ideas are in the surroundings as well. There are things you can do which play with the medium itself, where one can actually go ahead and play with the comic panels. The comic panels themselves help frame the narrative, move things forward in various ways. And one can actually play with that. For example, here, the discussion is about the nature of doing theoretical physics itself, which I think is important. Whenever you're talking about science, you should also talk about the process of doing science, not just the gee whiz facts, but how you come about those facts, how you discover them. So there's a discussion about the business of discovery in theoretical physics, especially when you don't know what the final answer is. And one of the things that I use here is the comic panels in the illustrating the idea of the jigsaw puzzle aspect of this whole story, this whole business that we do. And you're searching for pieces and putting them together. And sometimes you go off on a tangent that doesn't quite work. Something doesn't fit. And so the panels here guide you in various ways. You can see these sort of like an arrow taking you through that part of the page. See if I can use this, taking you through this part of the page, talking about the fact that you put things together, but then sometimes you get stuck. Your pieces don't fit. And so again, one is using the medium itself to help illustrate this important juncture in the discussion. And one can get a bit carried away. There's a whole discussion about spontaneous symmetry breaking and the Higgs mechanism. It gives rise to the Higgs particle, which gives rise to the masses of all the elementary particles. And I won't go into that here. Some of you may have heard talks about that. But there's a tempting analogy, which I couldn't help myself. I had to kind of illustrate involving Paradise Lost and breaking of symmetry and things like that. So I won't go into it here, but one can argue I got a bit carried away there. But anyway, there you go. So let's talk a little bit about methods, because people are usually interested in in how one does this and how I learned to do this. And a lot of it comes down just to drawing. And just as with science, people tend to wrongly, in my opinion, start saying things like, oh, I don't have the right kind of brain for this, I can't draw, what have you. And usually that's actually just nonsense. It's usually finding your way in, and it's usually having a go. The best way of learning how to draw is actually just to draw and to keep drawing and to actually use every little opportunity you get in a busy world to take opportunities to get something down, engage with the world. And eventually you build up your own style and your own way of doing things. And who's to say what a good or a bad drawing is? And there's a huge discussion to be had about that, which I don't have time for here. But let me encourage you to fall out of that habit. Just as I hope you are not in the habit of saying it about science, don't say it about drawing either, that you can either draw or you can't. It's nonsense. It's a learned skill, and you can get pretty good by practicing and learning the right kinds of things. And so that's what I did. I always doodled and sketched in various ways, but my drawings were not the kind of drawings you're going to be using to make a graphic novel. I had to go away and teach myself how to draw, how to study the face, the body, how to capture something in various ways again and again and again, because you're going to be doing thousands of drawings in the service of trying to communicate these ideas in a consistent way. So I carry a notebook with me wherever I go. I carry a little notebook which has shopping lists or partial calculations and things like that, but it also has sketches. And you sketch everything, people, all kinds of things. Buildings are fun, all kinds of things. Whatever will take your fancy. And eventually you build up a vocabulary, but then you have to then learn how to create the medium itself. There's something very specific about graphic novels and how they're constructed. And so I had to go away and learn that as well. And there are various ways of using different media and things like that, and bringing that into the computer to finish things off and things like that. Examples of process are kind of interesting. How is it that one makes a book like this? Is it just you write a bunch of words and then you draw some pictures? And yes, you can do that. But actually, I think when things are working best, these are all working together. And so at some point when I really was chugging along and things were working really well, I was actually coming up with whole narratives that began visually. This is an example of a tiny little thumbnail that was that began in one notebook and eventually became this finished page. That thumbnail is maybe like an inch or two across. Eventually, many years later, it became that page. And I was sort of coming up with the narrative visually, not writing words and then illustrating them. Although some parts of the book, especially early parts, were like that. Here's another example of a page where you're building things with pencil on actual paper. Maybe there was a rough sketch, that blue stuff in the background is a very rough sketch, and then it became a more detailed sketch, and eventually it became a more finished, polished piece of work. And then I added things like color and lettering, mostly using a computer, although some color was also painting watercolors and things as well on physical media. Here's another example. There's a discussion about the whole business of whether we invent mathematical ideas and the mathematical tools we use to describe nature, or whether they're out there in nature in some sense and we just discover them. It's an old discussion, but it was fun to think of ways of bringing out those ideas in a graphic form. And that again was somewhat visually constructed in how I wrote that before it became the finished page. This is a double page spread in the end, where you get to see a lot of this in a big fold out part of the book. Oftentimes people go, well, when a scientist is, well, not just a scientist, when someone who's supposed to be quote unquote an expert in one area of a field dabbles in another field, people find it necessary to ask the age-old question, well, what aspect of your own field was enhanced by dabbling over here? Because I think people somehow get uncomfortable with the idea that, you know, we can do more than one thing. So I usually jokingly answer the question with, okay, yes, I did make a discovery. I discovered an equation. So the equation is comics equals physics. And it's sort of joking, but it's actually, there is a serious point. The point being that as you look at these panels on a page, what you actually do as a reader, I give you 3 panels, and you do a lot more with those panels, right? You for example, move this person from here to here to here, and so you are inevitably constructing space. Your mind is immediately trying to put these things together, and you are constructing. You're doing the special effects, actually, if you like, and making this space come alive. But you're also making time come alive. What you're doing is you're creating a flow of time between these panels. And this character is moving through eventually. She's going to end up there. So what better medium to talk about physics than something that has the reader creating space and time? Because remember, physics is primarily about space and time, and the things that happen in it. And so you are in a medium reading about physics, in a medium that itself is something that you use, you construct the space and time. So that's something to take advantage of. I don't take advantage of it as much as I would like to, because I sort of discovered this, as it were, this natural adaptation between physics and comics, somewhat late in the process of making it. So I'm planning a volume 2, and I want to exploit this even more than I have in the current book. But this is part of my saying that what better medium for this? And so indeed, there's a sense of time that you get as you watch, for example, this panel that I showed before. There's a sense of time as he's watching this process happen. And actually, what happens in this book, in this story, is one of my favorite, and in my opinion, one of the most important stories. He actually watches something happen. He's surprised by what he sees. He goes to his sister, and actually they begin to try and figure out an explanation. So they come up with hypotheses about what he sees. And then they construct experiments in order to test the hypotheses, and then they do the experiment. So people often, when they see this story with the kids in the kitchen and the rice being cooked, they often go, well, what's that got to do with the rest of the book, right? There's stuff going on about discussions about grand ideas to do with the universe and string theory and the Higgs mechanism. And then there's this story with these kids, and that doesn't fit. And I would go, actually, it does fit. It fits more than any of the other single stories, because it is about the process of doing science. And so again, one gets to engage with characters in a visual way to explain, to describe what we do when we do science. And we make observations, hypotheses, design experiments, test the ideas, and move forward. And so that's what this story ended up being about. Going back to the business of comics and panels, panels being sort of the space and time, if you like, of the whole medium itself, one gets to then play with ideas and play with the panels in ways that I've already shown you. But here's another example where one has the panels dissolve on the page when one is actually talking about, as is hypothesized in various approaches to quantum gravity, that space and time itself in some sense can dissolve and lose its familiar form as you go into the quantum description. And so one can do that visually. This is a description of the discussion of the what we think might be happening in the interior of a black hole due to quantum physics. And one can sort of swirl in, because the panels arrangement helps guide the eye to swirl into the interior of the black hole and discuss what's going on. But time gets a bit funny when you go into the interior of a black hole as well as space. And one of the things I convey in this is that the time ordering of the panels gets messed up as well as you go into the interior. So one can be playful with the metaphor, the metaphors and the symbols and the characters and all of these things in various ways that help get the ideas across. So what are my hopes? My hopes for all of this is that people are going to increasingly recognize, and apparently since the book has come out and was reasonably successful, publishers and other scientists and authors of various kinds have really begun to embrace the idea, but it needs to be done more, embracing this idea that you can use this medium to communicate serious ideas to grown-up audiences in various ways, and they deserve to be not just in some corner of the bookshop in the graphic novel section now, but in the science book section, but actually I would hope everywhere in the bookstore. I would love to say that that's been happening a lot more in terms of how things are arranged in bookstores, but it's still the case. If you go into a bookstore to find my book, it'll either be in the science section or the graphic novel section. Some enterprising bookstores do recognize that it doesn't necessarily belong in one or the other, but both, and maybe just on that table in the part of the bookstore where you enter. And so I'd like to see more of that, books that defy categories and then help people engage and get over their stereotypes of what they think they like and what they don't like in terms of scientific ideas. So I think that's been happening. I hope it'll happen more. I hope that people put aside their expectations about comics and see that the form is incredibly powerful. And yes, other writers, scientists, artists, publishers, etc., will use the form to communicate ideas. So I think I'm going to stop there, and hopefully you might have some questions for me. So without further ado.
Thank you so much. That was a wonderful talk. And we do have a few questions in the Q&A. One person is asking, has level of interest been measured in for non-specialists who read these kind of narrative art forms? Has there been any type of quantitative look at increased interest based on books such as yours?
Interest in graphic novels that are geared at science or graphic novels in general? The two are different.
Interest in science, interest in understanding of science based on graphic novels such as yours.
Right. So as is usual with these things that often get labeled outreach, a lot of time can be spent worrying about how you measure things because people like measuring outcomes. Unfortunately, and I'm not saying this is the case for the questioner, unfortunately, people then tend to invert the whole thing and go, well, it's only important if you can measure it, which is a mistake. Happily, there are some anecdotal measures. I don't know if they're studies because there frankly aren't many examples. Of the kind I'm talking about. I should say, for example, Rebecca has been involved for years with using graphic narratives to communicate science ideas. You can find some of those, I guess, if you go to the APS website and search around. And there are other examples. If you like, for the more, if you like comics for grown-ups, whatever that means, mostly what was out there until mine came along was mostly graphic biographies, where you maybe have a few of the pages talk about the science, but it's mostly, the life of a quirky character. And that's awesome. That's a way of bringing people into science. But I think that, we can take it, right? People are curious about science and will read more about science. And I think editors and publishers allow them to. And so this claim that, as I found when I talked with lots of publishers, that, if it's a biography or an interesting character, we'll do it. But if it's just about the science, then no. And it's bizarre. And so what happened is that I eventually got a great partner, MIT Press, to work with me. And they came with me on this journey. And we published the book. And it is one of the most successful books they've ever put out. And so, that's a measure of something. Someone's buying those books. It's not just me buying it for my relatives. And I get email from people very regularly saying, I have never been interested in these topics before. I got this for my grandson because I thought it was for kids, but I ended up reading it and getting a copy for myself too. Those sorts of things I get regularly over the last few years since the book came out. So that's telling me that there is, as I always suspected, a thirst for this medium and to be used in this way. And people are asking when I'm going to do the next one. I wish I had time. I would have done it by now, but I'm trying my best to find some time. Publishers, I'm hearing from other book authors and also other publishers who are now sending me book proposals to review. They're going, oh, we're interested now in having a list where we have serious graphic science books. Can you help us choose some of these and things like that? So something is changing. I don't know whether what that'll turn into, but it's certainly different from how it was a few years ago.
Awesome. One comment came through. Thank you for sharing. My 8-year-old has just pulled out his computer and announced he's going to write a math comic.
Yes.
So that's not a question, that's a comment, but it needed to be shared. um, Someone asks for someone that's never read a graphic novel before, where do you start?
Oh, well, pick your favorite topic. It may be science, but it might be biography, or it might be memoir, it might be detectives, it might be science fiction, it might be superheroes. There's graphic novels in every such genre, just as there are prose novels. If you are of the more literary, whatever that means, persuasion, there are also graphic novels there. The boom in graphic novels and the realization that it isn't just pulp, it isn't just superheroes and stuff like that. That happened a long time ago, and then began to happen in the US a few decades ago, and especially in the last few decades. And so there are amazing books of all kinds. I'm just looking over at my bookshelf here. Right, if you let's do it.
Yay!
Like Proust, right?
Oh.
There you go. I don't know, all kinds of things. There's amazing masterpieces like this by David Mazzucchelli, which is all about an architect character. You could imagine this being, on the New York Times bestseller list as a prose book, but he did it as a graphic book, and it has the depths of emotion and human experience and all of those things that we look for in great literature. It's all there in graphic novels. I'm a big proponent of just learning by doing. So just dive in, and if you don't quite understand how it works, you'll figure it out. But if not, you can actually read books like the Scott McCloud book and the Hilary Shute book that I mentioned, the Will Eisner book, which tell you how the medium works. If you like how to read a graphic novel, or how to get a lot more out of it than you realize was in there when you read them. So there's a lot to be found in that world. But if you like, just start with my book.
I also recommend that. So for beginners, say graduate students and early career scientists, what steps would you recommend towards building the ability to communicate science through graphics? Should scientific journals give scientists opportunities to present their abstracts graphically? How can the physics community really harness this ability to communicate with graphics?
Well, I think we should maybe first of all, I think it begins immediately with realizing that we already do it. When I'm talking with another scientist in my field, it's very rare that I don't immediately start communicating with them graphically. And I don't just mean equations. I mean, I'm sort of, as I'm communicating, we're both at the board, for example, the chalkboard, or these days, the virtual chalkboard. And even if we haven't fully formed the idea, we're beginning to kind of draw lines that sort of have some sort of meaning and things like that. And some of it's real, some of it's imagined. It's sort of a mess in our brains, and we bring it out onto the page. And that's an incredibly powerful process, which is actually intimately related to the whole business of sketching. And I should maybe one of these days write a book about that. I think they're wonderfully connected. And so it starts there already, I would say, being less afraid of doing that with people other than our colleagues. And then when we begin to do our public talks and things like that, include, well, I think people are already pretty good about using visuals, but it's usually a picture of a big machine or a graph or what have you. Throw in some sketches. And we also need to get away from this business that people, as I said before, keep claiming that, oh, I'm too embarrassed to show my drawings. I can't draw. Drawings are remarkable. Drawings are like handwriting. They're these wonderful things that are very personal, can be very expressive. You get better at it by doing it. And who's to say that this handwriting is better than that handwriting, and so on and so forth, for the right sorts of applications. And I think we could just, the main point is that we should use more of the tools than we have available, when it comes to communicating. We've just been told, write a bunch of sophisticated sounding words in a 250-page book, and that's how you're supposed to communicate. And it's so we can communicate so much more, and we can reach so many more people in a variety of ways. And so I can't really draw a roadmap, because I think everyone comes to it differently. But the idea is just we need just use more of those visual tools, because it's already part of science. Just get it out there.
Awesome. So this next question is kind of a conglomeration of 3 or 4. Is work like this being used in classrooms? Do you use it in your work as a professor, as a teacher? Is it being used in educational settings?
I'm not sure just how much there is a dialogue between those two worlds, as it were, the world of being more visual and bringing it into the classroom. I certainly sketch a lot, and maybe a lot more, when I'm teaching things that I think physics is just intrinsically visual. So I can't give a lecture without drawing some sort of doodle that sort of gets across some of the ideas visually. I might do it more now than I had in the past, and I don't know if there's any movement, as it were, in you get a lot of people talking about physics education and things like that, very important things to discuss. I don't know how much there is a discussion in those contexts about the visual side of things. I simply don't know. I'm the wrong person to ask. I think there should be some research on it, and indeed I think there should be some research on effectiveness. There are important research pieces about the effectiveness of different modes of how you organize a classroom, for example. It'd be interesting to, alongside some of those research, to maybe also go, well, let's do this concept this way versus this visual way, and let's see how much of it sticks and how good people are at then explaining the idea, moving it forward and things like that. I think there's some great research to be done. It's all very early, although in my opinion, it's very late. When I realized 20 years ago that what I was reaching for was a graphic novel, and I sort of hit myself on the head and went, duh, then the next thought was, well, duh, the whole field. Why haven't we been doing this for decades? So I think we've a lot to do, including on the research side.
Awesome. I agree entirely. This is another kind of combination of several questions. Are there art classes or work specifically in scientific art? And is drawing for something like this, or for science, or for a science-focused graphic novel, different than, say, when you'd sketch, or some of the earlier sketches that you showed? Are there specific skills that are applicable to this versus in other forms?
I would say everything goes. Right. When I first started learning about this, because I'm very, very, very traditional, despite all of this, oh, I'm going to change this, I'm going to what have you, but I'm actually very, very traditional. So I read comics a lot as a kid in the 70s and 80s and what have you. And there's a particular look, because it was mostly then, for me, it was mostly superhero comics. And so there was a particular look and way of doing comics that then I was trying to see, well, how do you do that, right? When I now, recently came to do it, and then as I did more research, I realized that, well, a lot of the traditional ways of doing things, you can do it that way, but you don't have to. And so there are graphic novels now. There's such a variety of them. I'm just trying to think, if I just show you some pages, the different styles you get stuff which is extremely like it's a bunch of sketches, wonderful black and white drawings here by Gillian and Mariko Tamaki. This is a wonderful book, by the way. You get a very, very sort of clean graphic style like this. You'll get just trying to think of some other examples. So many. You get a sort of messier style. Oh, okay, this is one author drawing in about 10 different styles. He's pretending to be different different artistic styles. This is an amazing book. And it's just my point, because I'm rambling here, right? My point is that sketch style versus that clean style, that's all fair game. It's all part of sorry, I'm just trying to find yet completely different style, and I've lost it. I can't see all my books right now. But my point is that the main thing is the drawing. They're even, I'm not a huge fan of them, but they're even graphic books where people just take a bunch of pictures and make them as stills and then put word bubbles and you're done. Okay, and you know, that's a way of doing it. It's really up to you and the style that you're interested in creating, the atmosphere you're trying to create, and sorry, I'm really annoyed. I'm trying to find this particular book I was trying to find. And so I would say that learning how to draw and draw consistently so that you can communicate what you want to communicate and not be constantly getting frustrated by the fact that this didn't, you know, this character doesn't look like I wanted them to look 2 pages ago and what have you. That's where most of the time is spent, trying to be consistent so that you can then forget about it and get on with the job of communicating. So whatever style you learn and however you learn it is up to you. I, like a lot of theoretical physicists, tend to go for that sort of autodidactic way of doing things where I need a tool, so I'm just going to teach myself the tool. So I just dived, whatever the word is, and started learning how to draw. And then I love getting books about drawing. There's so many books about drawing. Everyone, you know, every now and again, someone becomes a master and then go, I have to write my book about drawing. And this is the way to draw. There's so many books. And the point is that you eventually realize that none of them have the answer. But it's kind of fun to see what they think the answer is. And then you go through all of them. And eventually, as you practice, you understand more about what it means to draw and what the process of drawing is, which isn't just about making a pretty picture. Then you begin to learn how to self-edit and how to focus on practicing this particular thing to improve this particular thing, and so on and so forth. And so I would say that's one way to go. But some people like to be taught a particular way. They like to sit at the feet of, you know, somebody who's going to teach them something. Go, you know, art classes of various kinds. One of the things that you can do is you know, look at your local community college or art school or what have you, and see whether they have classes for people who want to learn. A really useful thing in practice is drawing the human body. It is the most incredibly difficult and rewarding thing when you first start out, and you just do it by doing lots of it. And so you need human body. So I draw people out there in the world, but it's actually sometimes really great to go to places, what's called drop in and draw in some places, where there's a model and you can show up and draw in a safe environment. And not necessarily because there's someone there teaching you. Usually it's just some people show up and we're all going to draw this thing together. You have drink and draw and all kinds of other social drawing things as well. Look out for in your local city. Those are great ways of practicing. Urban sketchers, Google that. That's a wonderful movement where people just wander around cities and sketch things together. It's really great. So there's lots of ways of engaging with drawing. I
Awesome.
really went on there, didn't I?
It's fascinating, and I have a pen in my hand to write down your suggestions, so I appreciate it.
Oh, there
Um,
they are.
so we have time for one more question. And this
You're a
is
science fiction fan, sorry.
yeah,
Wonderful Octavia Butler books that have recently been done in graphic form. These are
oh,
amazing. Again, totally different style.
yeah.
Um, John Jennings is an amazing artist, and that's a totally different style from what I was showing you there. But previously, incredibly expressive drawings and colors and things like that. Anyway, sorry. Go ahead. You had another question.
So, one more question. Should science communication and particularly science communication through graphic novels and this type of graphic narrative, should that be part of a graduate school curriculum? Like, is this something that all scientists should know? And what might that look like?
Oh, that's tricky, right? Occasionally there's things like a required unit where you have to go and learn how to write an essay or something like that, right? In some aspect of your training. And it was already so hard getting that to be a thing. Imagine now trying to convince some of our more hidebound colleagues that more time needs to be taken out of the lab to learn how to draw or something. So I don't know what the answers are. Uh, I think I think, in my opinion, it is a good thing for scientists to learn how to communicate. Some people choose not to. They just want to stay in the lab or at the desk and do their science. And that's their choice. And so I am I think we have to be very careful about making things required. But I think there should be ways of giving people a chance to discover that they might like it. Um, so I think it would be nice for science departments to, for example, collaborate more with their colleagues in the arts and humanities, who have some skills when it comes to writing and drawing and things like that, and maybe come up with courses that can interest um, uh, some of those students. I think there's often a thirst for trying to find ways of revitalizing that corner of the campus, right, where the science departments are, and to get people doing all this cool stuff in new media and stuff like that. And we're just going, we want to teach you about F equals ma, please come. And so maybe one way of bringing new audiences is to team teach courses which have a bit of science and a bit of art and what have you. I think this could also be done with music and some other things as well. So there are some entrepreneurial ideas that could be tried. Easy to think of, hard to implement, because trying to do cross-disciplinary, cross-curriculum things can be difficult. But it'll never happen if people don't try. But at the very least, people can just bring stuff into their own classroom and try it out and infect people with that idea and see where it goes.
Awesome. Well, thank you so much. Every time I hear you speak, I just am in awe of what you do and how you do it. And I appreciate you spending your evening with us. So thank you so much. And thank you all for attending this lecture. And please look forward to our next events. So thanks and have a wonderful evening.